Hello, this is Dr. Mahmoud. Hello, this is Dr. Mahmoud Al-Odeh, and in this video, I'm going to talk about an example for the CP and CPK, how we could calculate the CP and the CPK. So the question here is a company producing kitchen worktops specified the length on one range at 120 centimeter plus minus 0.25 centimeter. This is the tolerances, plus minus 0.25. As a normal part of production monitoring, control charts were kept for such specific measures, and all output was inspected against specification limits. A request from the sales team for a tighter limits promoted the question of whether the limits could be reduced to plus minus zero point 0.1 centimeter, as this could result in significant orders from a new customer who prefer not to shave worktops to fit. Use control charts data, CP and CPK, to determine if the process is currently capable. Then use the new limits to determine if the new process will be capable to meet customer's need. Okay, so for this question, what I did, you need to record the data for as given, x1, x2, x3, and x4, and find the average, which probably it's given to you, but it doesn't hurt if you double check on that. And then find average of the averages, as I did here, and we did that in the X and R chart. Same thing for the range. Calculate the range, maximum minus the minimum for this set. The range should be from just only for x1 to x4. Same thing for the rest of the calculation. Let's double check one more time. So maximum between the x1 to x4. Same thing for the minimum, should be between x1 and x4. So the minimum should be to E3. All right, so now we have all the ranges, we have the averages. So now let's find the average for the range, or what we call the R bar. This would be 0.4. Okay, now let's do the calculation. The first thing that you want to do is the standard deviation. And the standard deviation, if you remember that we have an equation in the slides. The sigma is equal to R average divided by D2. And D2, it can be found in Appendix 2. You could go there and find the Appendix 2 and find if you have a number of observation for 4, the D would be equal to 2.059. 2.05. So if we divide the average of the R's, which is 0.4, by the D2, the value of D2, 2.059, that would give you the standard deviation. Somebody will say, okay, well, I could do something else. How about if I wanted to do the standard deviation for the sample, and I selected the averages for each observation? Well, this could be right. Yes, you could do this as long as all the team know about that you're using this technique, this strategy. If you standardize this process between your team, then you could go for it. It's not accurate, but however, it's helpful. You could get an answer. But the right way for doing it is to take the average of the R's divided by the D2 to find out what would be the sigma. Then now let's here on this table I listed the upper specification limit, which is for the current is 120 plus 0.25 is 120.25, and the same thing here, the lower specification limit is 119.75, and this is coming from 120 minus 0.25. For the proposed, the same thing, we are going to propose to add plus 0.1 minus 0.1, and this will give you the specification. And remember, the specification is not calculated, it's given to you by the customer, by requirements. This is they specified. It's not like the upper control limit where we do the calculation for that and use equations, but however, the specification, it's given to you. Starting with the CP, the CP would be equal to the upper specification limit minus the lower specification limit divided by the 6 sigma. Upper specification limit, G24, this cell right here in blue, minus the lower specification limit, J25, divided by 6 sigma, which is 6 times this number right here, the standard deviation. And this will give you 3.998. Now let's go to the CPK. The CPK is equal to the minimum between these two calculations, the upper specification minus the standard deviation, or mu, divided by 3 sigma, or sigma minus the lower specification divided by 3 sigma. So I did put this on a side to find out which one is the minimum. So I did started with the first one, which is the upper specification, 120.25, minus the average. Average of the average, which is the standard, the mu, or the x double bar, and this would give you divided by 3 sigma, of course, that would give you the 3.84. On the other side, we start with the average of the average, x double bar, minus the lower specification limit, so 120.01 minus 119.75 divided by 3 sigma, and this will give you 4.14. So we take the minimum between these two, and this will be the 3.8498. On the other side, for the proposed, we follow the same thing. We calculate the CP using this equation, upper specification minus the lower specification divided by the 6 sigma. And for the CPK, we find the minimum between these two and take them. As you see here, I did find the minimum, and I calculate the minimum to be the 1.45, and this is the CPK. All right, now what is the conclusion here? Is the process capable? Yes, the process is capable because the CP is above than 1. Is the process centered? Yes, because the CP and the CPK are almost equal to each other, so we consider them as a centered process. Can we move to the new proposed tolerances? Yes, we can, because it's still the process capable, the still process is centered. All right, well, this is all for this video. I hope this is helpful. Please let me know if you have any other questions. Thank you.